Hey guys, and today I want to talk to you about minerals. Alright, so we're going to start off by talking about what is a mineral. Well, there are 5 characteristics that make up a mineral. 1, they are definitely naturally occurring. They are inorganic, meaning that they are not living. They are always made of a solid. They have a definite chemical composition. And they are made of atoms that are arranged in a repeating pattern. This repeating pattern creates crystals, and we'll talk a little bit more about crystals in the next slide. So, crystal structure. A crystal is defined as a solid in which the atoms are arranged in repeating patterns. The illustrations below give you plenty of examples to go off of when it comes down to crystalline looking structures. And you should be familiar with this or have at least seen them somewhere. Now, minerals can form from the cooling of magma. Now, magma is usually found in the underground part of volcanoes, and small crystals form from rapidly cooling magma, whereas the larger crystals generally form from slowly cooling magma. So that's part of how they're formed. Now we want to talk about the identification of minerals and how we can recognize them. Now, scientists identify minerals based on their properties. Now, these properties would include chemical or physical properties, and the list will include that of color, luster, hardness, streak, specific gravity, cleavage or fracture, and crystal form. And I'm going to talk to you about most of these today. Now, color should be quite obvious. Unfortunately, it's probably the most least reliable trait when characterizing minerals because color can vary. Color can also change when exposed to moisture, such as high or low temperatures, or even from severe weathering. Now, hardness is a much more reliable feature. It's the measure of how easily a mineral can be scratched by other minerals. To compare hardness, a list of common minerals and their hardness was first developed by a scientist guy named Friedrich Mohs. He developed this system or scale, if you will, in which he appointed a softest measurement and a hardest measurement and labeled points between them. Now, this came to be known as the Mohs scale, with the softest being represented by 1 and 10 being represented by the hardest. Now, in the next slide, I want to show you a Mohs scale of hardness. If you notice on the top part of the scale, one of the softest materials is that of talc, and is represented by the number 1. Going all the way down to the hardest known mineral in this case is diamond. Diamond has the ability to scratch any other material. Talc, on the other hand, doesn't have this ability and can be scratched by just about every mineral out there. Now, luster refers to the way that a mineral reflects light from its surface. Luster can either be classified as metallic or non-metallic depending on the material. And the 2 examples, you have 2 minerals that both feature luster. However, the one on the top has a non-metallic luster, and the one on the bottom shows a metallic luster. Now, another feature that can be used to characterize minerals is specific gravity, and that is the ratio of a mineral's mass to the mass of an equal volume of water. Now, that might sound like a lot of wordy jargon, but what that really means is that if you have 2 minerals solids that occupy the same space and they take up the same space, but one weighs more or less, that is the ratio of specific gravity. This measurement can be very reliable when you're determining whether you have material. One example would be in the case of the challenge of gold versus fool's gold. A lot of times I like to ask people if they can tell the difference between gold and real gold, and some people can. By looking at them, they both have kind of a gold texture. However, specific gravity can be used to decide which is the real gold and which, in this case, is the fool's gold. And now, to determine which is real gold has a larger specific gravity than fool's gold, which is known as pyrite. Real gold is also much more dense. So if you were given a value of full gold to real gold in terms of specific gravity, you would be able to tell the difference. Now, another feature that can be used to classify minerals is that of streak. Streak refers to the color of a mineral when it is broken down into its powdered form. When a mineral is rubbed across the streak plate, the mineral that is left behind is powdered into a streak form. This streak test will only work for minerals that are softer than the streak plate. Now, the big question here is why? Obviously, if you have a harder substance that is working on a streak plate, it may not work successfully in the case with the mineral. So that's definitely a concern when you're rubbing the mineral. The next thing that you have to use to classify minerals is that of cleavage and fracture. Now, cleavage is a property that minerals have when they break along smooth, flat surfaces. Fracture is a property that minerals have when they break along rough, jagged surfaces. An example would be the likelihood of if you're tearing a piece of cardboard that's already has the lines in place would be an example of cleavage. And an example of fracture would be if you just took a piece of paper and just tore it in half or tore a piece of it, you'd notice that the paper would have fractured or jagged edges. So that's what I think of when I think of fracture. And cleavage refers to more of the cardboard or a sheet of paper that already has the dotted lines for easy tears. Now, along the lines of minerals, we want to talk about gems. A gemstone or gem is a piece of attractive mineral, and it can be cut and polished to make jewelry or other adornments. Most gemstones are hard, but some soft minerals are used in jewelry because of their luster. Now, in case with gemstones, rarity is another characteristic that lends value to those gemstones, and several gemstones have been assigned as birthstones. Now, one thing I need to compare, since we're talking about it, many times people look at minerals and rocks and group them together, however, they're very different. These are just a few of those differences that highlight the differences between minerals and rocks. First, rocks are made of minerals and other materials. Minerals are not made of rocks. Rocks do not form uniform structures like minerals. Lastly, rocks can be comprised of both inorganic, which is non-living, and organic solids. And so that covers just kind of the differences between rocks versus minerals.